welcome. This is our second meeting, and today so if you weren't here before, our first meeting, I base everything off of this book called Mastering Ethereum. It was written by Andreas A, and he wrote Before Mastering Bitcoin, if maybe you've heard of that, and also by Dr. Gavin Wood. He's one of the co-founders of Ethereum, and so pretty credible book. It's also on the Ethereum website as one of the resources to read. So this information isn't just from me. I try to pull from a credible source because, again, like I said, why should you trust me? You shouldn't at all. But so just an overview, like he mentioned, Shrum, we're gonna have a hackathon coming March 5th, and there's gonna be more details going out probably tomorrow. I'll send something out in the chat. If you're already in the Discord, I'll send more clarifications out there. But please join. We want as many people to join, beginners to experts here. Really, it's a good opportunity for you to just kind of get a feel of writing smart contracts, kind of working on a project. We're also going to be having workshops every Friday. So we do have meetings on Tuesdays and Fridays, same place, same time. But that on Fridays is going to be focused on just getting y'all prepped for this hackathon, because I know we're still learning. A lot of y'all okay, I've never programmed before, I'm still kind of learning. So that's going to help kind of accelerate that, get you guys in the feel of okay, how do I actually start putting this code into a project. So please come out to the Friday meetings if you are interested in showing up for this hackathon. But like he mentioned, a lot of prizes. If you have a dope project and Near likes it, you could win up to 50 to 100K. And obviously there's a typical hackathon prizes, 1,000 first place, second and third. And we'll also be having free food. And I know that's usually enough to get people going. But so that's with the hackathon. With the overview, we'll be talking about Ethereum's currency. So pretty much covering basics, whatever the book considers to be basics, and then I was talking about clients. So last meeting we talked a little bit about clients. People kind of interpret it as because a lot of times when you hear clients, you're thinking someone using that software, which is true, but a client is like an implementation of the Ethereum protocol. I'll go more into that. So we're going to be hitting on different accounts that there is on there. In our activity today, we're going to be actually setting up a wallet and also kind of deploying a smart contract. It's going to be a pretty simple smart contract. So this isn't the next groundbreaking DeFi protocol, if that's what you're interested in, but this is somewhere for you to start. And yeah, with enough talking, before, just a couple, did you raise your hand? Oh. So, before, this slide presentation does not have a lot of pictures. Try to not make it it's not as much information dense as the first meeting. I had to go back home for some personal reasons, so things came up. I'm only mentioning this because I really care about these meetings, obviously, and I really want to make sure I give you guys the best information and present it in the best way. So this won't be my best work, but I will try my best. And anything else in that? Yeah, I'm gonna try to keep it in 30 minutes and spend most of the time doing the activity. It's not just gonna be me talking up here. But enough said, let's get going. So Ethereum's currency. I actually have a clicker. I don't know why I don't have that. But Ethereum's currency. So the name. So a lot of people confuse and say, hey, dude, you own Ethereum. That's not actually what it's called. It's called Ether. That's the actual name of the currency. And it's if you see it on, I think we can call it a ticker symbol. But if you go to Coinbase, it's going to be ETH. So that's what you're going to see it as it classified. But when you're actually talking about, I'm trying to teach you guys from a programmer's perspective. And when you're actually working with kind of constructing the value of whether you're trying to write some code, sending money or whatever, you're not gonna be writing it in ETH. You're gonna actually be talking about it in what they call Wei. And so this is the smallest unit divisible. And the beauty about cryptocurrencies is that you can make them infinitely divisible. So if they wanted to, they could make this even smaller. So what's one Ethereum now? It's I think it's maybe 3,000 or something. So I can't really do the math off the top of my head, but one Ether is equivalent to 1 quintillion Weis. So what is that? That is 1 times 10 to the power of 18. So it's 18 zeros behind it. That's all the zeros you see. And when you're actually programming this in a smart contract, this is going to be represented by an unsigned integer. So for anyone that doesn't know what an unsigned integer is, it's simply just you know what an integer is, right? 0 to whatever. An unsigned, integer being negative infinity to whatever, but all 1 plus. But unsigned meaning that it starts at 0, so you can't represent negative ether, right? We wouldn't want that. So that's kind of a bit of the basics there. And these are the denominations. So there's different names. So you have the typical like SI, which is, I can't remember what exactly that means, but that's like the international, like the standard when you're talking about like kilometers, kilo whatever. But so you can refer it as that. Not a lot of people do. Wei is kind of like the common name that's used within the community, and they have a lot of different names for the different denominations. So you have Zabo, Finny, a lot of, like, those are kind of where you're gonna mainly hear Wei, maybe Zabo, you'll hear Finny, and then you'll hear Ether, obviously. It goes up to Grand and even Mega, but these are just different ways you can represent value ETH. And like I mentioned, when you're actually dealing with it, programming it, you're not gonna be talking about Ethereum, you're mainly gonna be denominating it in Wei. So, yeah.
I have a question.
Yes, sir.
When we pay gas, they call it like Wei with G. So
Wei.
I'm assuming that's the giveaway, is that what it is?
Giveaway. Actually, no, giveaway. No. Because it's not giveaway. I think the G-Way just stands for like, this is the gas unit of what you're paying for. So
I'm pretty sure it's like 1,000. It's like grand.
It's like a grand.
Yeah, I'm pretty sure that's what it is.
Okay, thank you for that. Is that right?
Yeah, like Kuwait, it's just like the price for usually the gas prices, like how many Kuwait you pay per unit of gas.
Yeah, exactly. So it's.
I don't know exactly how many Kuwait one way.
I think it's 1,000.
Usually gas prices are quoted in.
Yeah, they usually go in Gwei, so I think that's just its own name for using gas. Thank you, sir. Great question. Great question. But so Ethereum wallets. What are Ethereum wallets? You've probably heard of this. Maybe you've heard of like MetaMask, Coinbase Wallet, and anything. But a wallet is simply just like a software application. So you can think of it as your actual wallet. There's not much functionality. Actually, there's a bunch of things you can do compared to your actual wallet because it's obviously connected to the internet. But you could compare it a lot to the wallet you have. So it's really used to kind of manage your Ethereum account, sending, receiving cryptocurrencies. And there's different wallets. There's cryptocurrency specific wallets like MetaMask, which is Ethereum, and then there's also ones that are multi-currency, which if you use like Coinbase Wallet, which is a bunch of others I can't think off the top of my head, but you can also hold like ETH, Bitcoin, and a lot of those. So the functions of a wallet, like I mentioned, it's to hold your private keys. And really, a wallet is just, again, it's the user interface for you to be able to actually interact with the Ethereum protocol, because when on the Ethereum protocol itself, all it's storing is your private key. Actually, what it's storing is like your address and how much ether or whatever you have corresponding to that address. And so your private key is how you actually are able to access those funds and be able to send it. And you don't ever want to give anyone your private key. But so the difference is with the wallet is there's no company, even though a company does create it, they don't have access to your like actual private key. They can't see that information. It's kind of like its own standalone self-custody kind of application. So, but a wallet is one of its main job is to hold your private key, and then second is to broadcast transactions on your behalf. And you can change wallets pretty easily. So maybe you first started off with Coinbase Wallet, but you're like, that's a bit noobish. You know, everyone's like, you know, here's one thing I do want to mention. You really do, and then this will be probably in the following slides, but you really do want to have a wallet, because there's kind of this saying in the community is like, if it's not your keys, not your coins. So a wallet's pretty important, but you can change wallets. So like I mentioned, if you start with Coinbase Wallet and you're like, this is kind of noobish, I kind of want to move on to MetaMask and do a little bit more with it, then you can easily do that. So you just send funds to the new wallet, and then you kind of export your private keys from that wallet, and then import it to a new one. It's pretty simple. If you're interested in doing that, I bet there's a bunch of really great YouTube videos out there that can help explain it to you. And yeah, so the Fox, MetaMask, and the circle with the little square in the middle is Coinbase Wallet. And then Ledger, this is a hardware wallet, and we'll talk a little bit more about it, but not too much. But with wallets, with the fact that the Ethereum protocol is decentralized, comes with a lot of control. You have to take control of your own funds, but it also comes with a great amount of responsibility. Oh, skipped over it. So one crucial aspect that each user in Ethereum can do and really should, and I put a bullet on should, like I mentioned, if it's not your keys, not your wallet, is you should control your own private keys. And that's the first step to doing that is using your crypto wallet. And before a crypto wallet, it's a lot more difficult. So I wasn't obviously one of the early people in crypto, but I couldn't imagine actually trying to interact with the protocol itself by remembering this. I think your private key is like a 60 byte encoding. But why does anyone want to answer, like, why is controlling your private key such a big responsibility? Does anybody kind of have no? Yes. Jonathan?
If you lose your private key, you lose the funds.
Exactly. So a lot of people be like, yo, like I could lose all my money in the world. And it might put off people into kind of getting into crypto. But the way I look at it, and this is something I would elaborate it if we did Bitcoin 101, is that owning crypto is actually probably like the truest form of ownership when you're talking about owning any type of asset. Maybe you're owning stocks, maybe you own real estate or something like that. If you own stocks, really what the brokerage is saying is like, hey, I owe you this stock, but you don't actually own the paper certificate, because that's really what shows it. Maybe they're more modern, they use digital, but you don't actually own it. It's a representation that you own it and that they owe you. Now with land and like if you own real estate, you say, hey, no, I own that real estate. I know, I got the paperwork. The government can take it at any time, any moment. So that's one of the beauties of cryptocurrency, is that no one can take it away from you. So having the ability to actually own your private keys and truly know that no one can take it away from you, it can never be censored, is a big responsibility. But it's also one of the greatest forms of ownership, and ownership, especially in this country, is kind of how you, grow, build wealth, and a lot of things like that. So I won't go too much into this. You can look at the slide presentations, but this is tips for managing responsibility. To summarize, you don't want to improv. Use tried and tested ways. The more important the wallet, that means that if you have a lot of money in there, then the higher security you want to take. So you probably want to get a hardware wallet, and then really never ever store your private keys on something like digital, especially like don't put it on a Google Doc. I don't recommend putting it on your notes. Probably write it down on a piece of paper. And yeah, so that's really the main part. But if you do want to read more on the reason why I just put all the information out there is because this is probably really, really important. Again, you could possibly have millions and millions of dollars in your crypto wallet. You don't want to lose it. So you want to take the proper steps to making sure you're keeping it secure. And there's a lot more. There's a lot. But we'll talk about public and private networks. So when we get to activity where we're setting up our wallet, you'll see that there's different networks you can connect to. And so with Ethereum, there's a main network, and this is the main public blockchain. This is where there's real, I said W, it's supposed to be ETH, not WAIT. But there's real ETH on it, it's real value, so real consequences. You can, obviously I was typing this last night with horrible spelling. And then there's other test networks. This is the Ropsten, I think I'm saying it. I'm bad at pronouncing things. But this is just a test network. ETH here has no value. Then there's other ones. So Coven and Renkaby, that's what I think their name is. But the difference with like the other one is just that they use a different consensus protocol. So meaning that they're not actually kind of replicating what they're using a different protocol. They're not using proof of stake or proof of work. They're using what they call proof of authority. But really, it doesn't really matter because ETH has no value here. And most of these test networks are for what they sound like, for you to deploy contracts and just test it out. And that's really important. And there's also one you'll see like the local host 8545. And so this kind of just connects nodes, connects where running on your computer locally. So this is more of like a local network. And there's custom RPC, and RPC stands for remote procedure call. You can do a lot of cool things with it. We'll go more in depth about what it is, but all of these are just kind of the different networks you'll see. And last before we start the activity though, so there's different types of contracts. So we just talked about wallets. So that's the technical term for that is externally owned accounts. And these externally owned accounts, like I mentioned, your wallet, they're gonna store your private keys, and it gives you the ability to control and have access to your funds and even contracts, right? But second is contract accounts. So the biggest innovation with Ethereum is the fact that you could start writing code and have like smart contracts and actually execute those and actually make a promise on that code. Like, hey, I know this code will not change unless I deploy a new one and we decide to work with that new contract. So these are the two different types of contracts, and we'll actually be exploring both today and actually creating a wallet and a contract if you haven't already had a wallet. If you haven't deployed a contract, hopefully that is something new. But so with contracts, you're probably wondering like if there's no private key and it's kind of just controlled by if there's no private key, and it's just code, like who owns it, who controls it? Well, technically no one owns that contract. Once you deploy it out into the blockchain, it's controlled by the logic, right? So that's the beauty of it. So once you deploy a contract, you know that no one can go back and change it. It's immutable. And so it's controlled by the logic and the code that you write. And there's ways that you can write code to, say who is the owner of that contract currently, and there's ways that you can change that ownership later. But the functions and limitations of contracts is it has addresses just like your wallet, which you can send Ether to, and you can also send Ethereum from. You can also send Ethereum from those contracts. But the thing is, what makes contracts different than wallets is when you're calling a contract, you make a transaction and the destination is a contract address, you're actually executing the code on that. That's how you execute. For most people that programmed before, what you're doing, whenever you're actually executing some code, you're probably running it locally, and you're just pressing run, and it's getting executed there. Or maybe if you're actually connected, like with a big server and working with a company, different ways to do that. But so if there is a smart contract out that is deployed, simple way you actually execute that contract is to just kind of like send a message or call a transaction for it. Thing is, only externally owned contracts can initiate transactions. So that means that a smart contract cannot initiate a transaction, but what you can do is you can call a smart contract, and that smart contract then can call another smart contract. Kind of this chained contract calling. And so this is a bit of an example. You kind of simply see here so we'll talk a little bit more about what a message sender and everything is. But you have a person on your left right there. They call the contract, and then that contract maybe has a function that calls another contract, and this is the beauty of kind of it being open source. There's a lot of interoperability with different contracts in the network. So it's kind of like, the way to think about it, it's like you have a bunch of these APIs, and what an API is, for anyone that doesn't know, is a function. And what a function is practically just a set of instructions. So there's different things you can do, but the beauty of it is that you don't have to rewrite a bunch of code. So with all that being said, we will start the activity, but we're gonna actually typically what we wanna do is, there's a lot of people here that have never actually, programmed with Solidity before. So we're gonna walk, I have the VP here, Roshan, he's gonna walk through a Solidity 101 presentation, kind of give you guys an introduction to the syntax. And so while he's doing that, once he finished that, we'll start the actual activity. So yeah, Roshan.
So Solidity is, the reason why I'm telling you guys about Solidity is that Solidity is the main language that we use for smart contract development. So in Solidity, there's three main value types. There's booleans, integers, addresses. Booleans are your true false values. So anytime you want to run a certain section of code based on some condition, you're going to use booleans. Integers, they can be unsigned or signed. And you see that there's different sizes of integers from 8 bits to 256 bits. So anytime you're writing your code, you always want to try to pick the smallest integer that you can, that's compatible for the integer that you're using. And that's because the performing operations on a smaller integer costs less gas than performing operations on a bigger integer. And obviously there's limitations to having smaller integers, which you'll see on the next slide. And yet the last thing is addresses. So addresses basically give us the ability to own things. And for every account that you make on the blockchain, there's an address, and an address is like a public hash. It's like a hash function takes your public key, and then it runs it through the hash function and gives you the address. Yeah, so this is basically some sample initializations and declarations of booleans and integers. Does anyone know why the third line is in red? Anyone? Yeah.
278 is too big for an int 8.
Yeah, exactly. So because it's an 8-bit integer, you can only store numbers from -128 to 127. So a lot of the EC and CS people probably knew that, but yeah. And another thing to note is that Solidity doesn't have floating point numbers yet. So yeah, anytime you want to use let's say I wanted to use 22.5 in my program, you would just write 225 divided by 10, because those are both integers, and then you can divide legally in Solidity. these are the default values for these value types. So anytime you like don't actually declare the value, this is what you're gonna have automatically. That Solidity just puts in there. Strings are basically any sort of text variables that you want to have in your program, and so you can declare them using double quotes and single quotes. And yeah, so you see some sample declarations at the bottom, and then you'll often see strings declared as bytes 32. I think I made a typo here, but yeah, you'll often see them declared as bytes 32, and that's because performing operations on bytes 32 variables versus string variables is cheaper. And so just like a common theme you'll see is like whenever you're writing your programs on Solidity, you want to like do everything you can to reduce the amount of gas that the overall program takes to run. So yeah, this is just one of those things that you can do to minimize the gas. Arrays are like a collection of variables of the same type. So if I wanted to store everyone's name in here in like one area in a program, I would make an array. And if I think like the size is going to repeatedly change, or I want to keep adding people, or if I want to keep adding people or removing people, I would want to make a dynamic size array. But if I know that there's only going to be 50 people, then I would make a fixed size array. And indexing in arrays is 0. It starts with 0. So the first element in an array is indexed with 0 and so forth. So if I wanted the 25th element in an array, it would be index number 24. Mappings are hash tables, or it's like the Solidity equivalent of like hash tables and dictionaries in Java, Python, if you guys have used those. And so the big thing here is that it stores values in key value pairs. So it basically gives you a way to attribute like an arbitrary data type to another data type. And yeah, so this is a sample declaration at the bottom. On the next slide, you see, so if I was like making a game, and I've already made the game, and so it has like 100 levels, and there's 1,000 different people playing it. I could use a map to store what level each different user is on, what level each user is on. And so the best way to do this would be making a mapping like this. It would be public user level, and then whenever you want to access like the actual level that a user is at, you just get their user address, and then you would get the value by putting it inside brackets. Enums, this might be pretty new for most people. So enums basically allow you to create a type of variable that has like a limited number of things that it can store. So here I made an enum college year, and so there's only 4 different types of, or there's only 4 years that you can be in. You can be a freshman, sophomore, junior, senior. So this can be useful if I'm like getting some sort of user input, and I want to make sure that it's always like a valid choice. So by declaring like a variable that's like a college year, I can make sure I'm always going to get freshman, sophomore, junior, senior, and if somebody tries to put in like super senior, it doesn't work. Yeah, finally we have structs. So in your own programs, you'll probably be using this a lot. Structs are basically allowing you to make your own like data types entirely. So this is where you put the name, and then you can put as many members as you want inside the actual struct. And so you'll use the dot operator. So you put like the name of the instance of the struct that you just made, and then the dot, and then the member that you want. So this is a better example, but here they made a book struct, and it has 3 properties. It has title, author, and book ID. And so in the function at the bottom, if you want to access the book ID, they have like a get book ID function. You would just do return book and then dot book ID. So does anyone have any questions about what I just went over? All right.
So we're gonna finish out real quick in writing the smart contract. I did want to deploy it, but just to be respectful of you guys' time, because we have more stuff to cover, we'll just write this contract, and I'll kind of just walk through a bit of the code for. So place the most popular IDE. So what an IDE is like integrated development environment, and that's just where most programmers write code in. And if you're taking CS, then you already know this. But the most popular one for Ethereum is called Remix. Let's see. So if you look up Remix, you'll see it's one of the first links for Ethereum ID. The beauty of it is a actual web-based It's web-based, and the good thing about that is that you can easily connect to your wallet because it is already, your browser's connected. Your browser has your wallet, and so if you're doing it web-based, it's much easier. So when you get to Remix, you'll see there's a little button. It's really probably kind of small under where they say default workspace, and you'll click on this little page website to create a new one. And what we're essentially going to be doing is we're going to write a faucet. So where you just got the money, where you just got that test ether from, we're going to write a smart contract. So you can just name it faucet, because I do not know how to spell things. Faucet.sol. So you want to use a .sol extension just so that it knows that you're writing a Solidity contract. And so first thing when you're writing a smart contract is you kind of want to write, what they call is like the pragma. You want to write the pragma, and that's just telling you like what version of Solidity there is. And so with updates, with like different updates that come out, there's different ones. And right now, the most up-to-date one you'll see is 0.8.11. And so that's the first line. And if you've written code in like JavaScript, C++, or anything like that, then it's very similar. There's semicolons. Some people are like, I hate semicolons, but it's not that bad once you get used to it. It's not that bad when you get to it. It's only bad whenever you're debugging and you realize that you've only missed a semicolon. So we're gonna first thing we'll have is we're gonna initiate a contract. So this is like this is the kind of idea of a class. Another way to think about it is like an object. So just how Roshan showed you guys that example of like a book, right? And it's like you're creating like this like template of this object, this instance, right? And so essentially this is a lot different. This is gonna be different because it is just one version of like the contract you're deploying, but it's just the name of it. You're just saying, hey, I'm writing a contract for faucet, and we're gonna write the first function. So with a faucet, right, obviously you went to that faucet and you were able to withdraw ETH from it. You're able to withdraw ETH from it, and for those, obviously, if I'm like kind of going too fast, don't worry, you'll get good practice with crypto zombies. But so this is the function name. You went withdraw amount. So this is kind of how you just write a function. So you write function, the name of that function right there, and then here's parameter where you just pass in like arguments that you may need for it, and we're gonna call it. So because this is a function you'll use whenever you're actually like, yes. You are so right. Let's see. I've not used this. Can we zoom? There we go. Thank you, sir. No problem. But yeah. So you see, you went like we mentioned. I said you and it. You and it. Obviously, you're gonna make a lot of spelling mistakes when coding. But yeah. So we're calling it public. So public means that like anybody can call this function. So another function in your contract can call this function, and an external user can call this function as well. And so in the function, we're gonna have, so we wanna put a limit on the amount of Ethereum that someone can like ask to withdraw. So what Ethereum has is like its own, what they call like an assert, where it's you're testing some type of logic. And so the logic we'll use here is we want withdraw amount to be less than or equal to 1 ETH. And so what is 1 ETH? Remember, like I mentioned, you're gonna write this actually in way. So you're gonna put 18 zeros. So just count in your mind. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is essentially saying, hey, if this person tries to, yes.
Isn't UN spelled wrong?
You're a great man. Thank you, sir. There we go. Obviously, I don't know how to code. I don't know how to spell. So So what this assertion is saying is, hey, if anybody tries to withdraw a contract that is more than 1 Ethereum, tell them no, I cannot do that for you. And and then so what it requires, if someone does, then this contract is just going to stop. The execution of the contract will stop. It won't be able to run. The contract will get killed. And so just because it's going to obviously you failed the test, and you're going to see a failure message with an exception. So if you've programmed before, you kind of have an idea of what an exception is. If you don't understand anything I'm saying, don't worry. This is not the actual programming class you'll get. Do crypto zombies. So then finally, we actually want to send ETH. So they've requested less than 1 Ethereum, and then now we want to send ETH. So you saw this before, message sender. So this message is like a variable that every contract has access to. It's a global variable, so that's what it means to be a global variable. And it's just saying, hey, it's just the information that stores like who sent. It has different information like who sent this, who called this transaction, like a message, right? So a message is like what's getting sent through the network, and in Ethereum is what like transactions or whatever. So this just has information about transactions. And so one of the things that it stores is like who actually sent it. So you have the sender. And then another thing here that you have is you can transfer. So transfer that. And then what you want to transfer is the withdraw amount. Oh, doesn't want to do that. You want to transfer the withdraw amount. And this is essentially, that's it. That's literally the faucet that you just interacted with. It simply did this. But there is an error to this because of updates. You wanna what is it called? You wanna cast this. So there's a type called payable, and we're gonna use this in the next. Actually, we're not gonna use it in the next function, but you would have before. But you want to cast this to payable, so it's just letting the smart contract know that, hey, this sender is actually someone that can pay ETH, that can send ETH and receive ETH, and that's simply it, and that completes that function. And then last is contracts are able to send and receive ETH, and so the way you do that, even though it doesn't have a wallet, is the thing they call it a fallback. Call it a fallback function. Actually, you don't need it. We're not going to write anything in there. So a fallback function is like the default. It's like the default function in a contract. So just like if you had no other code or anything like that, you just had fallback and someone tried to send ETH, then the contract would be able to handle it. If you didn't have this function, then the ETH would have just went to the ether or something. I don't know. So this function just allows our contract to be able to actually receive ETH. And so if you have this contract's address, you then will be able to, this contract will be able to actually receive ETH and everything like that. I've just literally repeated that a couple times, but you guys get the gist of it. This is what you just interacted with when you requested Ethereum. We could deploy this. I want to end this in like 10 minutes, so I won't go through that. But to simply deploy it is you'll come here, you want to compile it just to make sure what you're doing when you're compiling is like, okay, did I actually write it correctly? Would it actually be turned into what machine code so that the network can actually run it? And it's taking a little bit to compile, but there you go. So it's been compiled now. And then if you go here, this is where if you want to actually deploy this into the test network, you put injected, and this is why we created your contract, because you then connect. And then now you're actually connected. As you see here, you have the ropes in network, and then you can deploy it. So, and deploying a contract costs ETH. Thankfully, we have enough ETH. I hope so. Yes, we do. I have 1.3 ETH. So you can deploy it, and now the contract's actually out there. And one interesting thing is, before I move on, is you can go here on your wallet and you can look at view Etherscan. So what Etherscan is a block explorer. So there's a lot of information out on the Ethereum network, and it's like be really hard for you to just kind of like, I don't know, open up that network and like go through and read it. So there's obviously been user interfaces that were made to help you be able to read the different information. But from your wallet, you can see all the different transactions that have happened. You can see all the different transactions that have happened. And so this is the transaction hash. This is who we got that Ethereum from if you use the faucet. And obviously it's a faucet, so they have a lot of out transactions happening. And you can see we received 0.3 ETH from there. I'm waiting. This is gonna show. There you go. Yeah. And then this is the one that I got from the MetaMask wallet. But then here you see contract creation. This is our address. If I match it here correctly, yeah, B5 something 70 at the end. B5 something 0 at the end. So yeah, that's just something really cool. You can see, you can actually, and that's why people talk about it. It's transparent and everything is, you can go up there and if your friend told you their address, then you could go look at every transaction they made. So Ethereum clients, what is actually an Ethereum client? So an Ethereum client is just a software application that implements the Ethereum specifications and like all the Ethereum specifications and the way it actually communicates over the network. And this specification is outlined by what they call an Ethereum yellow paper. So you've probably heard of a white paper, and that's what all these cryptocurrencies write to kind of give you an idea of what the project actually is, maybe how it works. But the Ethereum yellow paper is a lot more technical. It is actually a mathematical and a very formal kind of I guess proof, or just a way of specifying like, hey, this is how, if you're gonna write a Ethereum client, this is everything that software, that smart contract needs to follow and stand by. And does anyone want to answer this? So what does it mean to actually like be open source? I want to answer it.
Like anyone has access to it and can use it.
Exactly. So, like she said, to be open source, and that's what the whole like community means. But the beauty of open source, when we're specifically talking about clients, is that you can see how maybe someone that's like, hey, use my client and stuff. So, you know, because when you are using that client, most of the time is you're running a version of that client, right? You download the software, you're running and everything, and you're gonna connect your wallet to it. So if someone that was malicious actually put some back-end code to say, hey, once they connect their wallet, send me what their private key is and everything like that, like they can figure out a way to do that, then you're kind of screwed. So the beauty of it being open source is you can audit this code yourself. You can go through and say like, okay, how did they actually implement this? Are they following the specifications? And also that means when we're talking about the protocol and all the different clients, is with it being open source, a lot of other people can contribute to that. So like I said, anyone can audit it, anyone can read the code, and they can find a bug and then send a proposal and be like, hey, this should be fixed. This is going really bad. So that's the beauty of being open source, is the fact that anyone can access it. Because anyone can access it, anyone can contribute to the community. Now, like I mentioned, the Ethereum protocol implementation is specified by the yellow paper, and there's 6 main ones. There's parity, Guy, which means like Go ETH, C++ Ethereum, Pi Ethereum, Mantis, and Harmony. And the health, so why clients and why running like nodes and having and being able to download these clients and running it yourself is really important, is because that's what helps keep the network resilient. That's what keeps it censorship resistant. And so it's like you have a bunch of these different nodes that are all running the same thing. They all have a copy of the Ethereum blockchain. They all have this copy of every transaction that's happened on the network. And this is full nodes to be specific. And so this is really important, is because if one shuts down, let's say you have one in China, right? And China says, hey, we're not going to do any Bitcoin mining, whatever. We're going to ban it completely. Well, just because they shut down, that doesn't mean the network. That doesn't mean the network just stops working, right? Because you have a bunch of other people in different countries running the same code, keeping track of this ledger. So having these different client implementations is important, because another thing is like one client implementation might have a bug in it. So if there's a bunch of others like the 6 we mentioned, then you can just download that and run it, and you'll also be adding another node to the network. And the more nodes, the way to think about it is the more nodes, the more secure the network actually is. And so a full node, is when you download the client and you decide to have like all the history of every transaction that's ever happened on the blockchain. And there's advantages and disadvantages of it. I'm not gonna go through all of this. This was kind of late at night, so I just put everything down for you guys, especially if you want to go back over and read it if you are interested in running a node. But a few of them is, like I said, it supports the resilience and censorship resistance of the network. When you are running the client, when you are running a full node, you're the point of access to the actual network. So if you want to send a transaction, everything, you don't have to rely on some other node to do it. So remember, this is a decentralized protocol, decentralized system. You don't know if the node you connect to is some type of bad actor, that if you do connect to them and you do send a transaction, that they might just be reading through your data, ciphering through and collecting information about you. Like, you don't know that. So the advantages of running a full node is you are directly the one that connects yourself to the network. So you want to send a transaction, you're the one that kind of verifies that, and you can mine it in your own block or whatever. And so there's a lot of things with privacy, but the disadvantages, it requires a pretty significant hardware setup. It's going to cost a lot of money, and it's going to probably raise your electric bill. It takes a very long time for you to actually download it and sync it. So what I mean by syncing is you need to get a record of all the history before. And the thing is, when you download the history and you download all the blocks, is you have to verify them yourself. We're going to talk more about this when we talk about cryptography and kind of how the blockchain actually works. So, but you have to go through and verify all these transactions that's happened from the very beginning in 2015. And to be able to stay synced in the network and be a part of it, you're gonna have to kind of keep up with the change. So with the amount of data that is actually being uploaded each and every single day, like I mentioned, nothing ever goes away. Every time there's a transaction, anytime someone buys an NFT, that is added to the ledger. And so you can go from requiring a couple gigabytes to a whole bunch. And so there's public test networks. This is usually the same thing, about the same thing. Test networks are better because they're easier to sync, right? Lot less time, lot less data, everything like that. And you can easily just get Ether. You don't have to buy it, but that's the disadvantage. Ether here has no value, so you're really just using these to write smart contracts and make sure that they work the way that you want them to work. And so this is the same thing. This is what I kind of mentioned with the local host 85. I think it was 65 or 95, and yeah, so it's about the same, but we don't have time running through it. Running a client. So what does it actually take for you to actually run one of these clients, one of these implementations of the protocol? Is you're gonna need a CPU of 2 cores. This is minimum. This was written in 2018, so it's probably super out of date. But minimum at that time was 2 cores. You need at least 80 gigabytes of free space, which your computer now maybe has who knows how much gigabytes their computer has? Terabyte? Okay, big baller. Nah, but yeah, that's actually a lot. So you could run on your computer if you want, if you didn't want anything else to work. And you're gonna need 4 gigabytes of RAM with an SSD or 8 gigabytes. And this is a lot more specifications, but as you see, recommended is you'll want 16 gigabytes of RAM for that computer that you're gonna be using, a really fast CPU with 4 cores, and SSD with about 500 gigabytes of free space. I did delete the AG, so that shouldn't be there. I'll update this before I send it out. And also you want a really fast Wi-Fi connection. So this is a lot. If you actually kind of look all of this up and figure it out, it's probably gonna cost you a range of a couple thousands, not just 1 or 2, maybe in the tens. So not a lot of people actually run the full node themselves, but again, an advantage of running it is if you really do care about the security of the network, then you would want to contribute. And eventually, if I have enough money, I will actually run a full node myself. But the 2 most popular, like I mentioned before, Parity. Parity is just an implementation of the protocol, and it's a dApp browser and everything like that. It was written in Rust, and just one other thing I wanted to highlight, it was written by Dr. Gavin Wood mainly. And then Go Ethereum, that's another implementation written in Go. And this is developed by the Ethereum Foundation, so this is kind of the official one. But again, like I mentioned, is if they follow the yellow paper well, then it doesn't really matter which one you use. Now, remote clients are just wallets. So this just means you're not actually storing the full history of the blockchain there. So that means it's a lot faster to set up, and it stores a lot less data. And there's different functionalities here. And then to really summarize it, it's sending, receiving transactions, handles your private keys. and you're able to interact with smart contracts just like I showed you when we deployed it, and talks about injecting an instance of Web3, so really, and being able to interact with that instance. So what that means is when you actually are, if you've ever used like a Web3 application, what it's doing is, it's what you're showing is like just one moment of that of what actually is happening on the block. So it's gonna you're gonna request, be like, hey, I want to, like, let's say you go to Uniswap, I want to swap these tokens, and then so each time that you're kind of making a request to it, it's sending it back to the back end, which is the smart contract, and saying like, okay, what's the current state? What's actually sending to the network, saying, hey, what's the current state of the network, because it may be it might have changed since the time that I've actually last used this. So it's just kind of like injecting like, okay, this is the current state, this is the current state. But if you actually read web sites and all that, this is kind of like what they do anyway. So it's nothing that crazy. That being said, that is it. I hope today was a bit insightful. I'm sorry that it went a bit over time. Thank you guys so much for coming out. If you